quasi-mono, wafers is a hot subject now, but what are the challenges the manufacturers have in using this technology?
Yeah, so what we see with the quasi-mono is manufacturers need to get a very large fraction of the ingot to be monocrystalline. And what we see is that they get paid more money for those wafers that are really 100% monocrystalline. Those wafers can then use an alkaline texture in the cell making and get a good bump in efficiency, just 0.5% from the alkaline texture. So what they're really focused on is how to get most of the wafers to really be monocrystalline. And what they do today actually is they typically sort the wafers after the wafer manufacturing by eye, and will sort them by human. That's a challenge. And also, in addition, those wafers that actually do have even 100% mono, that should give you very good performance, have a very wide range of cell efficiencies, and that's due to some of the defects in the wafers that you don't see optically.
All right. Now, you've got a new product that's supposed to, handle some of these challenges. What are some of the key features that you have with this?
So what we're introducing at this show actually is 2 new inspection modules. The first one is an automated tool called G1 that inspects the crystallinity of the wafer and will tell you how much of the wafer is actually monocrystalline, and then that can be sorted into different price bins based on that. And then the second module, which works together with the G1, is our W2 module, and that's our new inline full-speed PL module. And what that will do is look at the wafer for electrical defects like dislocations and impurities. That will give you an efficiency drop in your cell, so that even if you have a 100% monocrystalline wafer, the W2 can tell you basically what efficiency you will get in the cell. And that's the real challenge that cell makers have today.
All right. Now, from a wafer producer's perspective, what is the business proposition for using this technology?
Yeah, so what they're trying to do is basically optimize the profit that they can get from each wafer. Either wafer manufacturers or cell manufacturers, or fully integrated players as well. And the best way to do that is to sort the wafers up front and process the wafer in the correct cell line to get the best efficiency you can get for that given wafer. Okay, and that may mean that you process it in a slightly different line that has a slightly different process. And with our tools, what we can do is sort those wafers into different batches that can then get the best efficiency and then the best price and the best profit from that given wafer, rather than just processing all different wafers together, paying the same price and getting a big range of efficiencies. So we can help that, we can automate that.
Now, I would assume, correct me if I'm wrong, but there's some other important uses for this tool.
Yeah, so what we have seen is that typically at the end of the wafer manufacturing line, customers today will sort wafers based on physical defects with optical inspection, but they really don't see that the efficiency limiting defects. We can do that, so what we see for casted mono, or the pseudo mono, is to have a 100% inspection there that will sort based on the efficiency you can get for that wafer. And then what we see on the cell making side is that you probably do an incoming quality check of some percentage of the wafers. And on both sides, they can use that data to improve the process as well. You can improve the casting on the wafer side, and you can actually improve the cell manufacturing process. When you know what efficiency the wafer should get, what it actually does get, then you can start tuning your cell line.